Hello, welcome to MTEN 304 Computational Material Science. Now in this video, we will delve into chapter 2 of our hands-on tutorial as per the structure by the handouts. And chapter 2 deals with modeling on Avogadro and then generating input files. But for this video in focus, we will just do an introductory concept basis as to what modeling stands for, and whereby modeling we talk about molecular modeling, and then the software in focus. We would look into some key features of the software that we will be using for this chapter during this week. So without further ado, we have to talk about what modeling really is about. And by modeling, like I said, it is what we're talking about molecular modeling. And molecular modeling is the process of building a digital representation of a molecule that is physically accurate enough for our quantum mechanical calculations. And as per quantum mechanical calculations, in our context, our DFT calculations. Now, to model molecular structures on Avogadro, which we'll get into later down the line, is pretty interesting. And I say interesting as per the fact that we model based on what we know is accurate. We define the system, and the system by default instinctively trusts our model to be what is accurately physically represented. So by so doing, that is what molecular modeling is about. And then Avogadro is one of the molecular editors used to sort of make a model, used to make a molecular model come to being and then subsequently used for simulations. And we use Avogadro in this class because, first of all, it is heavily user interactive in terms of graphically, and it has the basic little features which will be very easy to use and then comprehensive for our study. And to get to Avogadro, we first of all had to run or get some required items and programs on the list before having to start work on Avogadro. So first of all, when we delve back to our chapter 1, we realized that we needed to install the virtual workstation, which is the virtual box, and then install Quantum Mobile. And if I may go into it, we're required to have an operating system. So we're required to have a PC of this operating system, either Windows 8, 10, or 11. We wanted a minimum 4 GB RAM for smooth performance, and then a PC with a storage of 40 GB minimum. And in the course of our work, we would need stable internet and Wi-Fi connections for download, and then a browser. So if that was ticked out of the line, The sequence was as follows: that we would first of all install VirtualBox. Now, and then we'll download Quantum Mobile and run Quantum Mobile on the VirtualBox platform, and then configure Quantum Mobile, and then finally install Avogadro. So in the past week, I hope and expect that with the intro, each and every one of us were able to follow the easy to do steps with illustrative diagrams. And then more particularly, we installed this version of Quantum Mobile, that is 21.06.04. This is the preferred release for our subsequent studies, our studies now and then through the rest of the semester. So please kindly take notes. So upon downloading and importing Quantum Mobile, we run Quantum Mobile, and then we are expected to install Avogadro using the terminal with these commands. So we open the terminal, and then we type these line by line, waiting for each process to achieve completion. And after doing that, you would get your Avogadro pretty much installed and having this icon. So that was pretty much essentially for chapter 1, and now it's time to look into chapter 2. So with chapter 2, our key focus essentially is comprised of modeling basic molecules, building nanomaterials, performing encapsulation, and then finally using our results to generate what we call the Quantum Espresso input files. There will be a separate video session for input files, but this particular video focuses on features of Avogadro. So let's get into it. First of all, we open our Quantum Mobile. Right. Upon opening Quantum Mobile, we've reached straight ahead. Go and open Avogadro. I have my pre-installed. I have my installed already. Excuse my language. Right, so a plain Avogadro software would give you this display once the application is opened, and you're pretty much essentially going to go through all the various tools and how to use them in Avogadro. So beforehand, there is what we call the title bar, and the title bar contains the preferred name of your file, and every new page or work area comes as untitled.cml. Then we have the menu bar where we have file, and file 8 enables us to either add new pages, open existing models, or save as, or import and then export from various different libraries. Edit deals with whatever goes on directly in the work area. View changes the display and the alignments and the background color of our work area, and then we can center the models in focus. We have build, which gives us extra editing features. We have select, which aids in selection of individual atoms and then its bonds. Then we have extensions that gives us other built-in features within Avogadro. Crystallography settings, and then help. Now beneath it is the toolbar, or the quick access toolbar, and one of the quick access toolbars, this works for the file quick access toolbar, where you can, instead of having to go to file and drop down, you can access the most default options right here. And then again, beside it is what we are the toolbars in focus. So the first highlighted or toggled tool is what we call the draw tool. Now draw tool enables us to create atoms and bonds. And to create atoms and bonds in a draw tool, all we need is to ensure that, first of all, this tool is in focus and highlighted with a chamfered square around it. Then the next thing we do in this instance is to access the draw settings, which comprise element, bond order, and then adjust hydrogens. Now, element aids us to choose the particular element we want to represent in a ball and stick model that is on the worksheet. So the default element being toggled here is carbon, and we get to insert different elements, and then we get to also affect their bond orders as well. Now, to put in to insert an atom of a particular element in the work area, all we simply need to do is in any preferred area or portion of the worksheet, wherever your cursor goes, the moment you left click, you create what we call an atom. You introduce the elements or an atom of the element being highlighted in focus here, and that is carbon. Now we realize carbon comes because we clicked in the middle. For instance, if you do it over here again, carbon is in the center of the cursor. That's signaling, indicating that is where we have created our or introduced or inserted our atom. But it comes with other atoms seemingly visually bonded to it, and those atoms are as a result of having to toggle what we call adjust hydrogens. And adjust hydrogens by default puts hydrogen or attaches whatever elements we insert with automatically adjusted hydrogens. Now this comes in handy when we are dealing with more organic compounds and we need not to stress on how many hydrogens make the bond and what have you, but we we can untick this, and then no hydrogens will be automatically attached to the elements we insert. So with the same element in focus, if I come and left click, I introduce a single atom. Now there is a method of creating bonds, and creating bonds, first of all, we need to indicate whether the bond order or the number of bonds will be either a single bond or a double bond or triple, depending on how we want the settings. And once that is determined, all we need to do is, should we want to create a different bond, that is a bond of maybe carbon dioxide, which comprise carbon and oxygen. Once we have our carbon inserted, we can then go ahead and pick oxygen, and to create a bond with carbon, that is oxygen and carbon, we need to start from the atom already inserted, or the atom we want to bond with, which is already present in the work area, and then drag out of the atom, and we drag out holding the left mouse button and drag it out of the sphere of carbon, and then release to complete. So in the same vein, I drag out my oxygen out of the carbon by holding left click, pull it out of the carbon. You visibly see that another atom, which is red, comes directly out of the carbon. And then once it's gone out at any proportional or at any given length of our choice, we release. And once that is done, we know that we have created something. Now, for the same way that we can introduce, there is a method of removing or deleting atoms, and that is by the use of the right click button. So when I right click on this, I can individually take away atoms one after the other. If I take away the central atom, it goes with all the bonds in question. So that's how this is done. So this is CO2, which is one carbon and two oxygens, carbon dioxide as we popularly know it. And the next two we would discuss to this effect is the navigation tool. Navigation helps us rotate the view or zoom in and out. Now, to rotate the view, you can still hold the left hand button to rotate the view. Now, the rotation can go on in two different ways. First of all, it can go on all with the work, with respect to the work area. That is, the work area is our pivot, and we can do that with respect to the atom, any atom we leave our cursor on. So if my cursor is on any particular atom and I then rotate, I'm going to rotate with respect to the atom. So this is rotation with respect to the atom, rotation with respect to the work area. Now there's a third one that shows bond centric, and bond centric helps us to assess the bond angles within a particular model. So with this model in question, if I double click on it, it centers, and if I use a right hand, I can move it, or more or less translate it at different parts of the work area. If I add shifts, it counts with a level of zoom. Now straight to bond centric. Once the bond centric is toggled, and I hold and drag with left click, I may as well see the angle formed between the two oxygens and the carbon, the central carbon. Let me go to view and align to view with axis, and then give you a better way of viewing this. So that right. I'm afraid it isn't visible, but there is another way to assess the bond angle. The next one is manipulation. Manipulation helps us manually adjust atom lengths and then atom positions and then bond lengths manually. And this is randomly in no particular order, but to model a molecule accurately, we need to find the right angle and the right bond length as accurately represented physically and then theoretically. Now manipulation tool helps us move any atom in any bond in whatsoever direction we please. Then comes select, and selection helps us highlight different atoms in focus. When you click on any particular bond, the bond becomes highlighted in blue, and any atom, the atom becomes highlighted. Subsequently, we can select an entire area by left clicking from one end to the other, and then every species in that area will then become highlighted like that. And then once we've highlighted this, we can then, when we come back to manipulation, everything becomes a unit in terms of how to manipulate them. So highlights makes selection and planning processes easier, as we can manipulate two or more parts of a model with ease and seamlessly. The next one is the auto rotation, but before that, to undo a selection, we click on any empty work area space, right click, and we come back to normal. Auto rotation just rotates the entire species in a particular manner as determined by the direction and then the length at which we left drag. So left click drag in this direction, you would see a red line, and then once released, the molecule rotates in that particular direction and then pace, because for this particular tool the pace is proportional to the length of drag. So if the drag is as long as this end to end, you expect a faster pace. If it's as short, you expect a more slow, even like a more slower pace. To stop everything, we just press stop here, and then we go to reset, and then we can double click this to get the default positioning. And we have what we call the auto optimization tool, which helps us essentially navigate and then do what we call geometry optimization, but there is a better way to do that. The next tool is the measure settings. So in measure, when I click on one atom, it highlights as number 1. I go to number 2, and it gives me the distance between atom 1 and atom 2. Then if I go to atom 3, it gives me the distance between 2 and 3, and then the angle formed in there, which is close to 180, but it's 179.4 degrees. That being said, this is also one way of ascertaining the bond-centric manipulation too, because we not only will we find bond length between 2, but we find the angle between 3 atoms in a particular model, right? We do have for every setting in there, we do have its corresponding settings. For every tool, we do have what we call the tool settings, which changes and appears on the left. And then we have display settings, which is normally toggled. And with display settings, you can sort of enlarge it. With display settings, we can choose what we like to see in the display. So it's set to default ball and stick. I like to add label, and label helps me identify each atom. If I do away with this bond centric, yes, and double click, yes, label helps me to identify each atom. And then we have carbon, oxygen 1, oxygen 2 as displayed beautifully there. So you just have to go to display settings and then look for label and then take it to know this. Now essentially that would have been it for introduction to Avogadro, and then we continue molecular modeling and the nanotube, the nanomaterial encapsulations and what have we. But it's imperative that we come back to draw settings and then understand something, that to pick an element here is not all the elements that will be shown on the drop down menu. However, if I go to add, the periodic table pops up, and this periodic table can be adjusted and placed anywhere. So if let me center it like that. Beautiful. Now